Hey guys, I want to tell you how to add and subtract Rooty things, and for that I need to tell you about like terms. So with Rooty things, like terms means the same root, right? So they have to be third roots or square roots together, right? They can't be different roots, and they have to have the same argument. So the argument is the like number or variables or whatever's on the inside. And this like terms, right, is up to simplification. So you might have to simplify a little bit first before you see either the same root or the same argument. Cool? So I have here some examples. So here we have 2 cube root of 4 plus 5 cube root of 4, right? So the things we're counting are cube roots of 4, and there are a total of 7 of them here. So that's going to be 7 cube root of 4. Here I have negative the square root of 4 plus 1. You guys all know the square root of 4 is 2, right? So this is that up to simplification thing. So this would be negative 2 plus 1, which is really negative 1. On this last guy, I've got negative the square root of x times y plus twice the square root of x times y. So they're both square roots. They're both of x times y. Those are like terms. And I have a grand total of what? Negative 1 plus 2 is positive 1 square root of x times y. Cool? So those are like terms, right? They were all the same root and the same argument, at least after I simplified. These guys are a little different. So over here I have 2 cube root of 8 plus 4 square root of 8, right? The arguments are the same, the 8's are the same, but this one's taking cube roots of 8, and this one's taking square roots of 8. So even though I could simplify both of these a little bit, this one's still going to have, right, square root of 8 is 2 square roots of 2, and cube root of 8 is just 2. So the best I could do on simplifying this is make it 4 plus 8 square root of 2. 4 and 8 square root of 2 aren't like terms, so I can't add them. See that? So best I can do is simplify a little bit. Can't add. Here, I don't even know what I have negative cube root of 4 plus 1, and I don't even know what the cube root of 4 is. I can't even do any better than that. So this one's just done the way it is, and I can't combine them. On this last guy, I've got the square root of xy squared minus 2 square root of xy, right? The roots are the same, but the arguments are different. Pshaw, nothing I can do. I'm going to leave that one exactly the way it is. Cool? So this is what like terms look like. Alright, so I want to remind you guys of some rules that work for roots. So these are 2 rules you're allowed to do. These are the only 2 rules you're allowed to do. So things that look like these but aren't allowed. Cool? So you are allowed the nth root of a times b is the nth root of a times the nth root of b. And you're allowed that the nth root of a over b is the nth root of a over the nth root of b. Those really look a lot like the exponent rules, and there's a good reason for that. Because really roots are kind of exponents, right? So, for example, say I wanted to simplify the square root of 50. I don't know something that squares to 50, but 50 is made out of 25 times 2, which is made out of 5 times 5. And so this pair, right, means that I can pull a 5 out of this thing and be left with a square root of 2. You guys see that? Really, that's me thinking I have the square root of 25 times the square root of 2. Cool? So, boom, simplified. If I wanted to do an example with the other one, say I wanted to simplify the cube root of 32 divided by the cube root of 8. So, I think I could say, all right, the cube root of things on the top divided by cube root of things on the bottom may as well be written as the cube root of 32 over 8. Right? And then I know how to divide 8 into 32, so I get the cube root of 4 out of it. So let's see some of that to combine. So here's my kind of ultimate example. This is really the thing I want you guys to take out of this section. So I want to add 7 square root of 20 minus 2 square root of 45. Okay, so if I want to add 7 square root of 20, let's see, 20 is 4 times 5, right? I know how to square root 4. So this is 7 times the square root of 4 times the square root of 5 for the first bit. And 45 is 5 times 9. So I can make that into this 2 times the square root of 9 times the square root of 5. And then we can simplify a little bit here. So I get 14 square root of 5 minus 6 square root of 5, which is, all told, 8 square roots of 5. Cool? Alright. The only other thing I need you guys to take out of this section is I need you to be careful. Okay? Be careful. Square root of y squared is not y. Okay? In other words, when you're squaring a variable on the inside and then square rooting, that's not necessarily just y, because this function, right, outputs both positive and negative values, right? This function only outputs positive values. This thing is actually the absolute value of y. Okay? So you have to be a little careful with these. Cool? Think about it a minute. Try plugging a few numbers in there, and I think you'll see what I mean.